Yeah, she fell down hard. But okay, so we're going to go over the review sheet in just a second. We have a test next time. Kitty cat. We have a test next time. Focus for me, okay? Um, so if you don't have your purple notebook out, you probably should, because we're going to go over the review sheet. The review sheet is on page 16. Maybe 15? What page is that, Yo-Yo? 15? Um, so it's on page 15. After we go over the review sheet, I'm going to ask that you let me see it, that you're actually following along. I'll come around and check it. Some of you have done some great work right now. Given the fire drill and what happened out there, we're going to have to, I'll check it in a minute instead. People at home or on the class right now, tomorrow, whenever, well, wait, if I'm watching it tomorrow and I say tomorrow, is that actually the next? Okay, that's too meta. But the people at home, the sub's going to check it after you're done watching the video. So you have to come and bring it up to him or her. Before we get too deep, I want to talk about an eventual quiz that's coming up. It's an element quiz. You see down here in the blue, it says you need to start studying for element quiz 1. Open your purple notebook to page VII. That's near the front. Flip to the front of your notebook. Yeah, you're on it. Good job, Canes. So if you look on page VII, there are 2 groups of elements. What does the first group start with and end with? Starts with aluminum, ends with antimony. I just want to make sure people see the boundaries. It goes from aluminum to antimony, right? Some of those, Canes already knows. She knows that carbon is C and oxygen is O. But others, when I look at that list and I say, hey, what's germanium? She says, I don't know, it's probably in Europe somewhere. So she may have to make a flashcard for that one. And that's what I would like you to do after the test. I'll have some note cards and you guys can go ahead and fill them out and make a flashcard. Canes's list is going to be a lot shorter than Blue's. Blue doesn't know any of them. She can't tell carbon from calcium from oxygen. She's never even heard those words before. So she's going to have to make all of them. Whereas Canes is going to just break it down to 12 or 13 because she's so much better. Secondly, what does this quiz look like? That's Canes's real question. That's why her hand is so high in the air flailing around. That quiz is going to be on the 11th or 12th. I can't quite remember. But it's not next class, because next class is the test. It's the class after that. All right? There's going to be 2 types of questions on that test. The question will either say antimony, and you write SB, right? Because SpongeBob found antimony, which is why it's SB. That's not true. Just a lot of people struggle with SB, so I decided to tie SpongeBob to antimony so that people might accidentally think of SpongeBob and antimony like it was anti-money and he didn't really care about money or something. I don't know. Or strike that, reverse it. Let's say that it says Fe. What is Fe? Iron. Now, you're supposed to spell it correctly. I do allow some leeway. I am not the best speller on the planet. I'm probably on the bottom 10%, actually, not the top 10%. I would just like it to be spelled close enough that when someone read it, they'd be like, he was trying to write carbon. He put an extra R in there. Relax. Right. Like the pirate version, carbon, or something like that. So that quiz, again, will be on the 11th. I also want to make it really clear, just because I didn't one year, there was this guy who was wearing his Michigan State shirt, and he thought it was matching. It was not matching. He tried to match every name with the elements that they don't go with. So he literally got a 0 out of 27 on it because they were not matching. You have to know these are the most common words we use throughout the year, these elements, and so make sure you review them. Are there any elements on that list you don't know how to say? On the top list. There's 2 lists, aren't there? The other list we'll talk about a different day. But just bismuth. I don't like bismuth because I feel like I'm saying it wrong. Bismuth. I mean, who? Muth. I don't. Yeah, bismuth. It's BI, I think. Is BI? Yeah. Are there any others that are kind of funky to say? We just did bismuth. What's the symbol? Beryllium. Not beryllium. That would have two R's. It's beryllium, one R. Tungsten, W. Tungsten is actually a German. It was found in Germany. And in Germany, they call it Wolfram. They call it Wolfram in Germany. Here we call it tungsten. When it was discovered in England, they called it tungsten. When it was first discovered, though, in Germany, they got to name it and give the symbol. And a lot of the names and symbols are usually decided by who found it or created it first. So on the periodic table, there's a bunch of elements that are named after famous people who were either involved in the discovery, or in the case of Berkeley, the University of California at Berkeley, you usually just hear it called Berkeley. They tried to get their entire name on the periodic table. They are actually the American University of Berkeley at California. That's the full name. And they have Americium, Berkelium, and Californium on the periodic table. But they couldn't get that one element before another group did. And so Universitium doesn't exist. In its place is Curium, which is a good element. It's named after Mary Curie. Yes, Michigan State, do you have a question? Nope, just scratching. You're allowed to do that. Well, I just recorded that. All right. Yeah, you scratch too sometimes. So goofball. Okay, so again, all the element stuff is not next class. Next class is a test. How about we go over the review sheet and talk about the test a bunch as we go? Yay! All right. Odd clapping. All right, let me pause for just a second. Okay, so the first part of this is about significant figures, and I wrote the three basics up there. How often do we count a lefty zero? We never count them. This audience is a good one. You guys got lucky. Never. They are never counted. What about trap zeros? Always. Ooh, he changed colors, except he can't spell. And then S's are optional. And then righties are funky, right? Righties, it depends on whether or not they put a decimal. They are decimal dependent. So if someone puts a decimal, it counts. So these are 3 sig figs. Someone doesn't put a decimal, then the zeros don't count. And so you have to look and see whether or not there's a decimal. And a good example of that would be like if I handed Aladdin over there a weight, and I said, how much does this weigh? And then she said, yeah, her name is Aladdin. She said 30, and really she's just taking a guess because she's holding it in her hand. Then she walks over to one of those fancy digital scales, sets it down, and the scale goes 30.0. It's no longer a guess, and you still need to be able to tell people these zeros matter because the scale worked so hard. And so we have this system of telling people when things matter or are significant and when they don't. Okay? I'm just going to jot down the answers to the first 6, and then we'll have a brief. I'm going to pause while I write. And that's one of the secrets to life right there. So as I was doing this, I've got these leading zeros or left zeros trapped and righties. And I'm thinking about each one. Number 1, I only said it had 2 significant figures. Which value is the estimate in 12 kilometers? The 2. And then the second one, it's the 8, right? And the third one, it's the 4. Which is the estimate in number 4? The very first one, yeah. So when someone has only one significant figure, that one significant figure is the guess. So they're saying like, I don't know, it took like 1,000 seconds. I have no idea. I wasn't paying any attention. And then the others, we have some lefty zeros, some trapped, and some ones to the right. Do you all, fine people of the classroom, have a question at all? No? Lacrosse is good? Are those lacrosse sticks? No, okay. All right, we're going to cruise down to the scientific notation. I want to remind you when you do scientific notation, you have one number, the decimal, the rest of the numbers, followed by times 10 to the whatever it is. If it's a big number, then that would be a positive exponent. If it's a decimal number, it would be a negative exponent. So this one here, it'd be like 1.25 times 10 to the 4th. Cool. Thank you, Knez. I really appreciate the help. Number 8, we have 2.02 times 10 to the negative 2. Yeah. This one, I have trouble counting on the screen here. I think I have to move it 6 times. So it'd be negative 6. Number 10 is a horrible use of scientific notation. This is a number that should not be used, but we're forced to, so I'm going to anyway. 5.4331 times 10 to the 7th. I want to point out it's 5 point. There's one number and then the decimal. You don't put like 2 or 3 numbers and then the decimal. There's only one number and then the decimal for proper scientific notation, because we are trying to tell people that, did I switch? Yeah. It's 5 times 10 million. It's 5 times 10 million. What is 5 times 10 million? 50 million. 50 million. And so we're telling people what the value of this number is by using the 10 to the piece. And then these last two are goofy uses of scientific notation. And I cannot write on here very well. Sorry, guys, at home or in class. 9.81 times 10 to the minus 1. 1.26 times 10 to the... You could put to the first, couldn't you? Or you could just leave it as times 10. Because 10 to the first and 10... I know. She leaned to the... She was like, look at that leaning one. All right, checker. Plaid. All right, yeah. Okay, now we're on to the dimensional analysis portion of the game. I want to remind you, you write down the given, followed by whatever unit. Let's just say the unit was X. All right, let's say the unit was X. And then you make a little train track, and where should X go if it's the unit in the next step? On the bottom. And then let's say we're changing it to Z's, whatever they are. And then we fill in the numbers that connect. My pen is like refusing to write. Here we go. The numbers that connect Z and X together. An example of that might be like 1 year, 365 days. So those two numbers connect those units together. So each of these examples is worked out showing that. You can see that I wrote down the given and the unit, and then I put its copy of it down on the bottom, because if it starts and then ends up on the bottom, what happens to the centimeters if they're in the given and in the bottom in the next cell? They cancel. Yep, they cancel. And then we have to put whatever we're trying to convert it to, or what we know it's equal to. Now, we do probably need to remember King Henry died by drinking chocolate milk. I'm going to grab my eraser and erase that random thing. And so for this one, I have to think to myself, which is bigger, a centimeter or a millimeter? A centimeter is slightly bigger than a millimeter. It's 10 times bigger, so I guess it's not that slight. But you can also tell that by looking at... That's still the eraser. By looking at this list here, the K is the biggest of all the values, and then you get smaller, 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 smaller. And as you change, give me a second, Conez. As you change from the big one to the small one, the K is made of 10 of those. It's made of 100 of those, 1,000 of those, 10,000 of those. I keep adding a 0. 100,000 of those, it'd be 1,000,000 millis. So if you had 1 kilometer, it would be 1,000,000 millimeters. And you can do that with any one of these, really. So since we're doing centimeters and meters, 1 centimeter is 10 times bigger than a millimeter. As you go to the right, they're smaller and smaller, by a factor of 10. So each shift is 10 times smaller. So what I did is I said 1 centimeter is 10 millis. That make sense there? Knez, do you have a question? I can always count on Knez for good questions. She would like me to point out that its K, H, and D are capitalized because they're the bigger ones, so they're capitalized. And then once you cross the base unit, they become lowercase because they're the smaller side. That was almost like done intentionally or something. At least it's done intentionally by me. I don't know if it's done intentionally by the rest of the world, but honestly, you're in my world now, so you deal with me. All right, it's Murphy's world. So the KHD are the bigger ones, which is why they're capitalized. Does that help actually remember? Capital, big, lowercase, small. That's my goal, right? So I got my setup. Things cancel. Now that it all cancels, I grab my calculator and I math, right? I'm multiplying 8.43 times 10. Those of you who want to push divided by 1, feel free. But it's 8.43 times 10, and if it's on the bottom, you're dividing, so divided by 1. Number 14, pretty much the same thing. I have 241 centimeters, so the bottom has centimeters. This time, though, the centimeter is the smaller unit. Why is my pen not reacting? So the centimeter is the smaller unit. Meter is the base unit, and it is 2 steps away from the base unit. So 1 meter, 2 steps away, 100 centimeters. I want to make that clear. How many zeros are 100? 2. And the meter and the centimeter are 2 steps away. That's why there's 2 zeros. It's every value is 10 times different. Now I have a setup. Centimeters cancel, meters don't cancel. So then I pick up my calculator and go 241 times 1 divided by 100, right? Cool. All right, scrolling all the way down. Take a look at those. I'm going to pause so that you guys can analyze them for a second, then we'll come right back. So let's go on to the next one. The group here had no questions, so I'm assuming y'all at home have no questions also. And y'all, yes, I'm from the South. I'm from Virginia. We are literally the seat of the South. So number 17, 8.7 kilograms changing into grams. So if you have grams, you got to put grams on the bottom. Then you have to figure out who's bigger, grams or kilograms. And so I'm going to write down K, base unit, chocolate milk. And the kilos here and the grams are there. So the king is bigger, so I put 1 with the kilo and 1,000 with the grams because it's 3 steps away, so 3 zeros. And then I grab my calculator. Yes, I'll give you calculators for the test so that everyone's on the same playing field. Not all of us have a built-in calculator in our brain. Okay? And so we'll do the math. Boom. Number 18 could be done 2 ways. I typically go to the base unit. That's my standard go-to move, is I go to the base unit. But I had a kid this one time 4,000 or 5,000 years ago, and he said, couldn't I just do 10.6 decigrams and then decigrams to milligrams right there? And I was like, by Jove, of course you can. And he put these 2 numbers in there. Did he put the right 2 numbers in there, 1 and 100? Yeah, because deci is 1. Well, come on, why can't I write in the top of the screen? That's really getting irritating. Yeah, deci is 2 steps away from milli, so it is a 1 to 100 relationship. And so that answer in orange is the same answer as in purple. They're both demonstrating the same thing. How to convert units using the right ratios. Sometimes there's different ratios that mean the same thing. And then they get the answer. I would grade both of those the same way. If Yo-Yo did this way, you'd be great, all right? And if right behind, well, I don't have a nickname for a Zipper. If Zipper did this way, then that would be fine. They would both get the 3 points because they're showing the right process. They're doing the work the right way. Now, let's say that for some reason, Zipper's answer only is 106, while Yo-Yo's is 1,060. Zipper's doing all the right work. He got the wrong answer. He gets 3 out of 4. You got the right answer also. You get 4 out of 4. Whereas Cola think we already did this example, but cola only has the right answer and no work. The answer is only worth 1 point. I am looking at the work. That's what I care about. Because when we move forward to the other weird units, grams, moles, atoms, things that don't make any sense yet, you need to know how to use dimensional analysis to solve those problems. Yes, Plaid. You can do it a way that is kind of like dimensional analysis, then I'm good with that. So if you're doing like the, times, and they look like little ratios, that's the same thing. I just use the train tracks because my handwriting are so bad. And the less mistakes okay? But it's literally the same thing though. Down to number 19, I had a question from Arrow over there. Arrow was wondering if she had to put her answer in scientific notation. You don't have to, Arrow. If you want to put 0.0051, that's fine, because that's the same number. It's just that the calculator did the math, and the calculator said, it's scientific notation time, and it did it in scientific notation. Have you seen a number appear in scientific notation in your calculator yet? Yeah, it says E. It would say 5 point, that's wrong. 5.1 E minus 3, that's kind of how it would look like in the calculator, but better handwriting. And the E represents times 10. I'm not sure why the Texas Instrument people, with their huge calculator empire, can't make times 10 appear. I don't understand that. But that's what it is, okay? So if you see an E in there, that's not for everyone. That means times 10. Yeah. All right. Kitty Cat will catch up in a second. All right. Moving on to math. I am confident that Rose can type numbers in a calculator and calculate math. I think she can do 97.38 plus 4.3 plus 8.1, and the calculator will spit out an answer. I'm not testing that. I'm testing, can Rose round, based off of the rules we discussed. We discussed 2 rules for rounding. We discussed if it's adding or subtracting, and I'm circling them up here. We look at the decimal places. When the decimal places don't exist, our answer doesn't show those. So what I mean, Rose, is in this question right here, it says 4.3, and then there's nothing after the 3. We don't have a decimal place there. Our answer can't have a value there. So with adding and subtracting, we look at where the decimal places end, where we run out of decimal places, and that's what happens in this answer. You still do the math normal, but then you round it based off of that. Cool, Rose? All right. And so that's why it's 109.8. We're dropping everything after the 7, which means it rounds up. What if it's multiplying and dividing? Well, that veteran there can tell you if it's multiplying or dividing, then we go with the sig figs, right? Yes. Those of you playing at home, I'm pretty much just looking at their shirts and calling them by a name kind of slightly related to their shirt in some way. She's not actually a veteran at the age of 16. That would be really weird. Oh, no, I'm not. Well, can't say. We don't really know how old she is. It's okay. All right. Evidently, I don't. Well, they can't hear you. They don't know you're 32. It's fine. So when we're multiplying and dividing, we go for the significant figures. So in 23, we're multiplying these 2 numbers that are in scientific notation together. Whoa, just all over the place, aren't I? We're multiplying these 2 numbers that are in scientific notation together. The first number has 2 significant figures, 5.1. What about the scientific notation? That has no impact on it. 5.1 is 2 sig figs. The 10 to the stuff is all zeros that don't get counted. They're the lefty zeros that don't get counted. So it's really just those 2 sig figs. The other number was 2.82 times 10 to the, again, 2.82 is how many sig figs? 3. So if you had to choose between 2 sig figs or 3 sig figs, you go with the lesser of the two. Anytime you're multiplying or dividing, you go with the smaller number of sig figs. And so I got this answer in the calculator. What are the first two sig figs in that answer? The 1 and the 4. So I just want the 1 and the 4, and everything after that gets dropped off. If Arrow wants to write it out longhand, she could. She could write 0.00000014. If Michigan State back there wants to put it in scientific notation, that's also good. All right? You could do it either way. It doesn't force you to do one way or the other here. Cool? Secondly, I could see the whale back there making a minor error by changing from scientific to normal notation, just making a slight error. Maybe he doesn't move the zeros far enough or whatever. Why do that? Can your calculator do scientific notation better than you? Whale? Yeah. He shakes his head no, but I know he's lying. So just put that number in parentheses. Parentheses, 5.1 times 10. Use the little caret thing, and then minus 4. Close the parentheses down, and your calculator's like, that's the number right there. I can handle that. And it'll handle the numbers just fine. It's more likely that we mess up the numbers when we shift them from scientific to normal and back again. So I suggest you just put parentheses around them, and the calculator knows what you mean. If you leave the parentheses off, sometimes your calculator doesn't know what you mean. So if you type a number in scientific notation, put parentheses around the number. All right, that's my hint for the entire year. I'll repeat that one about 47,000 times. Yes, Kanez. So to clarify for Kanez here, when we add these values together, bam, 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 yeah, our calculator spits this out. We have to round it. We have to round it so that we get the right answer based off of the rules of significant figures. That's what we're doing here. And so what I did in number 22, the one I skipped, this one had 3 decimal places, the second one had 2 decimal places, and the last one had 4 decimal places. 2 decimal places is the weakest number, so my answer only goes 2 decimal places. And then everything else just disappears. It rounds. All right? This is the real reason rounding was taught when you guys did rounding in elementary school, but then they're like, wait, pump the brakes. They're not ready for sig figs yet. It's not really the reason it was taught. All right, moving on. Good? All right. More math. Yay, we're dividing there. That's what that slash means. 35 divided by 0.62. Which rule do we use if we're dividing? Are we looking at decimal places or significant figures? Aladdin? Aladdin says significant figures because Aladdin knows everything. Did you use the genie for that one? No. So the answer comes out like this in the calculator. This long 56.45 blah, 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 blah. We have to only round it for 2 significant figures. So we drop all that other nonsense off, and it's just 56. And the same thing, kind of similar idea to what Kanez was asking about a minute ago. Number 25, we're subtracting. We're looking at those decimal places. Somebody precisely measured something and has 2 decimal places, and then they subtracted a random amount from it. If you have a really precise value minus an estimate, your answer is an estimate. And so you have to drop the decimal places. How do you suppose, I'm trying to come up with a couple more nicknames. You know, Daddy Longlegs is, I've got to pause for a second. Someone just said Daddy Longlegs, and So, number 26, we are averaging, and this is a pretty average question. You take the 4 values and you add them together, and then since there's 4 values, you divide by 4, and that gives you the average. Guess why the average has 3 significant figures? Yes, the numbers that you were working with had 3 significant figures, so your answer really shouldn't be better than the values you're working with, because they all had 3 sig figs. You could even do that from a decimal perspective. Each of the values had 2 decimals. Guess how many decimals the answer has? Right. It happens to work with both ways. Hey, Mr. Murphy, but 4 4 has one significant figure. I would argue that 4 has infinite significant figures because it's actually a counted value. How many numbers are you adding together? 4, right? This 1, 2, 3, 4 numbers, and that's a fact, so it's actually an infinite sig fig example. Alrighty. Then we come to 27. It's got this, I forgot what it's called, percent error. I'm not going to ask any percent error questions on the test. I don't want you to worry too much about knowing the equation. But the way that works is you subtract what you think the right answer is from what your answer is, and then you divide it by the accepted value, and you get a percentage. If you had around 2%, you were doing fine. This does present a Sigfig Conundrum. There's actually 2 math operations going on. Typically with these, I'm just looking to see that Rose's answer is kind of close to my answer. So if you have about 2, 2.18 or 2.08, I don't remember what the unrounded version was, I would be happy either way. Because there's actually subtraction going on and then division, and you kind of end up losing significant figures, and that's not really the goal. And as we move forward and we have more math problems and other chapters, I'll be looking to see that you round them, but that you just round them kind of reasonably, that you're thinking about some of these sig fig rules. If COLA says, 2.17 and it's supposed to be 2.18, I'm probably not going to go after him on future tests. But if he says 2.17057700009er, I'm like, what the heck, COLA? Round a little bit. Okay? So I would ask that you try to hold on to these rules, but I'm not going to make them destroy your grade. If Calvin is consistently doing it wrong, I might grab a point here or there, but if it's just once or twice. 28 is a good time to discuss the fact that there's a couple of vocab words in this chapter. They were all listed in the very beginning of the unit on the calendar. It's a good idea to always go through that calendar and see what some of the vocab was. Precision and accuracy are 2 similar terms. If I gave you a bad instrument and then you had to go measure something, could you measure it consistently wrong? And then your answers would be precise, but they wouldn't be the right answers. They would not be accurate. To be accurate means to be right. To be precise means to be consistent. All right. So those values there. When I say consistent, the number in B, the right answer, the estimate is that value there that I just underlined, that 0. And the others, their estimate is the only thing that really kind of varies. If that was just slightly higher, it'd be 100. So they're all about 100. Whereas in A, these are not these are not close to the estimate. They're all off by about 20% or so. So they're not accurate, but are those 4 answers in A close to each other? So they're consistent. And then the person in C is just a train wreck. I mean, look, ethanol is supposed to boil at 78. They've got it boiling at 61, 46, and 101. They've made some major errors at some point. That's just all over the place. It's a disaster, isn't it? That would be like I handed the brain alcohol. She boiled it off and it was like, oh, I'm supposed to boil it twice. And she filled the beaker up with water the second time. Alcohols and water have very different boiling point. And we do a couple I'm going to pause. So I would go through my notes. If I was preparing, I would go through the different examples, maybe rework something. And come in with questions next class. I will take questions for a couple minutes before the test, but we're not going to spend 20 or 30 minutes. I'm not going to go, you need to know this, okay, Arrow? You need to know this, boys in the hood. I'm gonna just say, what questions do you have for me? All right? We go in this class from like full training wheels on day 1, where I like kind of drag you through a problem, to day 2, where I show you the answers and start to like, do you guys have any questions? To day 3, which is like, I almost give you I just make you ask me questions directly, and then take the test. All right? Yes, Kanez. Oops. Yes. Knez would like you to know that there's actually 27 elements on the list, not 23. The typo has been eradicated and move forward. It's also really important that you